Well, thank you again for taking part in our discussion today. We're going to focus on AI, ML, data science, and network automation. My name is Sean Kinney. I'm the editor-in-chief at RCR Wireless News. You can follow my work there and on our sister site, Enterprise IoT Insights. I'd also encourage you to check out my podcast, Will 5G Change the World? We get into a lot of the topics that we're going to see today during the presentations, and I'm excited to introduce the panel for you today. Presenting after me, we'll have Mr. Damian Rose. He's a Senior Product Manager, Mobile Signaling and Analytics at VIX. And Mr. Prakash Sangam, Founder and Principal at Tantra Analyst. To take you through the agenda here, first I'm going to share a few quick housekeeping notes. We're recording the session today, and a video of the presentations will be made available later on the RCR Wireless News YouTube channel. There's also a companion report that goes a little deeper into these topics and some other very important ancillary topics. That'll be sent out to registrants next week, so keep an eye out for that. And we've got time reserved toward the end of our session today to take questions from the audience, so please send those in throughout our conversation and we'll get to as many of those as possible. Quickly on the agenda, I'm going to start things off and go through AI ML-based network automation and give you a little bit of an idea of what the long-term promise of network automation is. We've got a special guest that's going to give some commentary on that. And then we're going to look at kind of where we are today with some examples from some key vendors and operators. After that, Damian's going to take us through a presentation examining how a data-first approach to operational excellence can really help you use your network to deliver high-impact, high-value use cases to your customers. And then Prakash is going to talk to us about some of the trends around the distribution of AI throughout the network, even out onto devices, and go into what that means in the context of increasingly complex 5G networks and increasingly data-intensive applications. So let's get started here. And another reminder, just please submit your questions throughout the presentations. We'll get to as many of those as we can. So AI ML-based network automation, the promise and the reality. So to be clear, the long-term goal here is to use intelligent software systems to automate as many network processes as possible. One of the reasons the industry is moving in this direction has to do strictly with operational cost reduction, pure and simple. But when we think about the proliferation of 5G and the evolution from just enhanced mobile broadband for consumers, which by and large is where we're at today, and then on to eMBB as well as massive IoT and ultra reliable low latency communications, you're serving not just consumers, but really any type of enterprise and any type of enterprise application. So this contemplates a very different type of network and architecture that is cloud native and highly distributed. So in this world, the complexity of the network and the need for real-time responsiveness to support mission-critical types of use cases, it means that automation is imperative. You know, people are just not capable of operating this thing the way that it needs to be done. So you've got to look to these intelligent software systems. I want to quickly distinguish between some of the terms here. So AI is a larger discipline, and it's about equipping machines to simulate human behavior, decision-making, emotional response, so forth. Right now in telecoms, AI not really widely used in the network. On the customer service side, though, you'll see AI-based chatbots and voice care interfaces. The idea here is to facilitate an interaction between a customer that doesn't require that customer to engage directly with a person, but still get a positive outcome. So if you're the operator, you can deliver on this, you're deflecting calls and you're retaining customers. Machine learning is a subset of AI. The idea here is to give a machine access to data inputs that let that machine continuously learn from the data and improve decision-making within some set of given parameters. So when we think about a 5G-enabled enterprise use case, maybe smart manufacturing, that one comes up a lot. So think of a computer vision system that's running machine learning algorithms for quality assurance. You show the software a bunch of examples of what a good or acceptable product looks like. So when it sees a new product, whatever you're making, come across that line, it compares the new product it has not seen before to what it knows is a good product, and then it makes a determination. So the more iterations of that good or bad product that it sees, the better its decision-making process becomes. So that's just one example. And then I wanted to mention deep learning for the sake of being thorough, but this doesn't come up a lot in strictly telecoms discussions. Ancillary perhaps, but you'll see deep learning come up in conversations around autonomous driving. This is really a hierarchical approach to use neural networks to sort of recreate the way your brain ingests and understands information. So in autonomous driving, the vision systems would use deep learning to basically take apart image inputs and understand what they're seeing. Is it a bike? Is it a scooter, pedestrian, another car, so on. So before we look at what's happening today, I wanted to share with you a vision for the future of network autonomy. I mentioned we had a special guest here to share some thoughts. So I've got a video clip from Tariq Amin, CTO of Rakuten Mobile and EVP of Rakuten. This clip's about 3 minutes, and I just want you to appreciate that while what he's laying out here is a very complicated prospect, it is something that's attainable.
We look at our mobile network in Japan, considered to be our big lab. We are in a unique position that allows us to push the envelope in technology. I am not hindered by any legacy thinking about how to approach network architecture. My team is not afraid to venture on the creation of effective cost and components, and we are really good at it, Sean. We are very good at understanding component engineering and understand the benefits of what excites us when we talk about open RAN or open interfaces. I think what is really misunderstood, Sean, we are thrilled about it, not just because of commoditization of radio access, but the benefit of what automation could bring. I mentioned this so many times before, that scratching the surface is a statement that is really underestimated on what I meant. I could see an absolute trajectory to the analogy of what car industry is doing today to achieve full autonomous driving. I assure you, Sean, I see it every day, that in my network architecture, to achieve autonomous network in which my operation team doesn't have to do a thing to run and manage this network is within reach. I actually tell my team, I said, I want you to be lazy, my friends. I want you to be lazy by making sure that what you do every day is about code. Network as a code is what your mind needs to be programmed about. Elevate your intelligence, push the envelope. Now, you package all these experiences and say the platform play. So Rakuten Communication Platform, I'm very optimistic. And I'm optimistic because the approach that we are taking, and I mentioned this many times before, really, truly, we don't want to be another vendor. That is far away from it. We just want to provide a platform that provides efficiencies, and most importantly, recognize we alone cannot carry this journey by ourselves. So the platform will be open. The platform will be built on co-innovation. We might even open it up if others are interested in investing into such an idea on a platform. We'll be very open to discuss to anybody to become part of this, this transformation. So, and when you look holistically about the overall technology stack of what we are doing, you start from Rakuten Communication Platform, starts from a state-of-the-art Kubernetes management infrastructure, followed by an application orchestration that I think is built on a lightweight orchestration system that is built as cloud native, that's built as a scalable architecture, a very simple marketplace that allows you to consume both IT and network application from a single pane of view, and an OSS platform with our recent acquisition of NOI enables us to change this industry upside down on how you offer OSS, and you see how much money gets spent on OSS and DSS. We want to completely transform all of this.
Okay, so that's sort of the vision for network autonomy. I know you're all familiar with what Rakuten Mobile's done there in Japan. Rakuten Communications Platform is essentially a packaging of that for export to other operators, enterprises, government, so forth. But really a lot going on there. That's the future. So what's happening today? I'm sure you're all familiar with network slicing. This is part and parcel of the value proposition of 5G. You're using software to create a logical virtual partition across a network, and that'll deliver the network resources that's needed by, X application, whatever that might be. So by matching the needs of an application exactly with the resources, the user has a good experience, the operator uses their network in the most efficient way possible. This is envisioned as something that's done dynamically. So if you're an enterprise and you connect 100 HD cameras to the network detects those cameras and resource loads appropriately, and the work that is put in by people is quite minimal. So Nokia is addressing this through a product suite they announced late last year, and what they've done is they've connected this up across the core, transport, and radio networks. So network management tools and domain orchestration solutions are making the appropriate network resources available for whatever that application is. In their example, they talked about autonomous drones. But to make sure those resources stay in place as the drone, in this case, operates, they're using a closed loop analytical approach to constantly monitor and optimize operation. In the context of network slicing and really, industrial 5G, this is important because this is how you, the operator, deliver against the service level agreement that you've entered into with your customer. You can see in the quote up there, this recurring emphasis on responsive dynamic software. On the right side of your screen, you've got a diagram that shows you how a customer would use a portal. They would order up a slice based on the parameters that they need for the application that they're trying to do. And the network would create that slice across the core, transport, RAN domains, and deliver it on to the end device. And so this is a very low touch process. Now I wanted to look at another example. This is Orange and HPE applying AI-based automation in pursuit of Industry 4.0 efforts, specifically digitization of manufacturing. So at a high level here, Orange made available a slice of its public network to support this precision manufacturing robot that needs really high throughput, really high reliability, and very low latency. So at one of Orange's labs in Brittany, France, they fitted this robot up with a 5G radio, and they put cloud management or management software rather into a local open 5G core. That core is running HPE and CASA systems, cloud native network functions, and HPE provided network orchestration software. So what they were trying to do here is, one, get the robot working properly, and then interrupt that proper operation, and then let the network correct the problem without any sort of human intervention. So to do that, they connected the robot, gave it its dedicated slice, and then they started to manipulate the throughput and latency available over that slice to disrupt the operation. Network's able to detect those deviations from the set quality of service parameters that the robot needs. And what specifically happens is an alarm gets triggered in the orchestration software, which then automatically creates a concurrent slice and moves the robot over to that new slice that is adhering to those throughput, latency, reliability thresholds. And this happened with zero touches. And in this kind of case, precision robotics, responsiveness, something you measure in milliseconds, not seconds. I've got a quote up there from Orange. I mentioned at the beginning of my presentation that automation it's necessary for real-time network experiences, and you see that language come up again automation is necessary for the real-time enterprise. So there's lots of examples out there. I just picked those two because they kind of stick to this theme of using intelligent software systems that use AI and ML for automation in pursuit of creating new services. And once you can reliably create and deliver these new services, now you're talking about service monetization. So to recap a few of the key points, automation obviously has a straight line to your operational cost that goes into TCO. Tarek talked a little bit about TCO as it relates to the Rakuten communication platforms. And he also hit on the need for kind of new types of skill sets, particularly around software development. I think if the more you look at this topic, the more you'll hear about the need for a software and for a data first approach to doing network automation. And then latency. This ties directly back to Orange's comment about the real-time enterprise. You can spend billions of dollars on a 5G network that can deliver latency in these single-digit milliseconds, but to make use of that in a meaningful way, you've got to automate your operation. Then service level agreements. At the beginning, I discussed how 5G today is consumer facing and all about enhanced mobile broadband. That's an important development, but by and large, not really making anybody any money. So to monetize these services, it's going to be all about the enterprises that are going to have these widely variable needs. So that's why your network has to be flexible and responsive. You've got to meet these customers where they are, and that's where you can create these new revenue opportunities. And you're not going to maintain these new revenue lines unless you're able to strictly adhere to these SLAs. I've got a quote up there from Morgan Stern from Itential. They're a automation software specialist. Services are no longer static. They change as customer needs change. Automation is critical to create a dependable and seamless experience. So, I think that pretty well sums up my thinking on this topic. So I'm going to leave it there and turn things over to Damian Rose of Bix for his presentation.
Hey, thanks a lot for the intro and presentation, Sean. Really interesting stuff there. All right, so I'm going to shift the focus a little bit and look a bit on the approaches that players in telecoms have been taking or can take to actually make the most of machine learning and AI in their day-to-day operations. A lot of what's being said about AI and machine learning is, I wouldn't say theoretical, but very future-oriented, not addressing today's challenges. And it's good sometimes to just take that step back and look at what's happening in the real world today and how can we apply this. And the first step is actually understanding that it has to be a data-first approach. If you go to the next slide for me there, please. Everything in terms of your understanding of where machine learning, artificial intelligence, or data science in general can take not just your business, but the operations of your business in the future starts from your understanding of what data you have, how available it is to different systems and tools, and how to make the most of that data to either automate in this case, or leverage in some way to bring greater value to your business. Telecoms, in a nutshell, is very complex just by its nature when we talk about the various networks, network generations, technologies, and hardware that comes with that, but also the intangibles, the variety of customers that we serve and the different needs each customer has, the various ways of segmenting. And also the fact that, in telecoms or as a mobile operator, you're not just looking at your local operations, the customer you serve in your demographic region or country, but also the international customers you serve who are roamers, who may be visiting your network and that you may have very little understanding about what their behavior patterns, trends, and needs are, but nonetheless, you have to serve them and deliver the level of quality that you and your roaming partners have agreed to do. So all of this complexity makes the job of being a mobile operator and somehow driving efficiency through automation an extremely difficult challenge. Just move on to that next slide for me, please. Now, when we talk about automation, there are several things that especially mobile operators are hoping to achieve. I mean, it ranges from everything from increasing capex efficiency and return on investment on the network and resources that they have deployed, to also reducing the operational expenses, which can be a significant part of the business expenses. In a lot of cases as well, the driver may be to improve quality of experience, to deliver that high-end experience that differentiates themselves from their competition when it comes to the end user. Also looking at how to maybe efficiently utilize network and human resources. It's one thing to ensure that your network resources are deployed or configured in an optimal way, but you also have your human resources, and you want to make sure that they're being used in a way that makes them most effective to your bottom line. And then finally, there's also, you know, the management and planning of the network. When do I need additional capacity? How do I actually adapt processes to make sure that time isn't lost, you know, chasing wild gooses? So there are a lot of reasons why automation becomes interesting, and the use cases in a lot of cases are either not clear or don't apply to some mobile operators. Now, what do we mean by this? There are some general use cases, so network design, load balancing, network coverage, capacity optimization. These are general concepts that I think everyone would understand, and we can see a way forward to automating these by making software-defined networks make decisions on a day-to-day basis and remove the complexity and time that is lost when we allow humans to do this. It can be very time-consuming. But there are other use cases that are more niche. For example, virtual digital assistants. You know, not every market or every customer base is open to the idea of speaking to a machine, and to the extent that you can make VDA impersonate a human interaction seamlessly, may determine whether or not it's something that's viable for you. There's also the concept of intelligent customer relationship management and the systems behind that. Automating this in some cases may be feasible if your data is accessible, if it is clean, if you actually have accurate and reliable customer data that you can actually pump into a CRM tool and then automate the processes behind it for customer engagement or customer nurturing. Everything comes back to the data quality issues that you have to tackle as well. And then there's also cybersecurity. In some regions, cybersecurity is a real issue, North America, Europe, etc. In some cases, it's not, and it may not then be a focal point. So I'm saying all this to point out that any adventure into applying data science, specifically artificial intelligence and machine learning projects, should start from the use case and the data behind that use case to make sure it's solid. And once you've identified use cases that apply to you, your business, your region, your customers, then we look at how do we then create value. So you also need to see that you can actually tackle high value use cases that are customer centric and are creating the type of deliverables that you need for it to make sense. And then this part of it is interesting. It's good to, you know, sit and do the research with teams and come up with interesting use cases. But at some point, this needs to be productized, or as I put it here, it needs to be made scalable. So this needs to be something that can work in the real world and at the scale that the real world demands, with both speed, performance, and accuracy. So there's a little bit of equation that operators have a difficulty solving, which is, you know, do I have the resources in-house that I can utilize, you know, my data science team? Have I identified the use cases that are meaningful to me and my operations, not globally interesting and useful, but meaningful to what I'm doing and my reality? And also, can I scale this and ensure that it's actually something that I can operate now, tomorrow, and in the long term? So this is a model I think we need to always start from, whether it be a mobile operator or any other player in the business who is looking at automation. How can I do this step by step? Okay, the next slide, please. Now, I mentioned to you before that you know, the use cases vary, and one of the things we sometimes I think forget is, again, the fact that telecoms, it's not just about the local network. Rolling out 5G, for example, to serve domestic use cases, you know, connected cities, smart buildings, you know, Industry 4.0, yes, that's there, but then you have those other scenarios again, which are, as I mentioned before, roaming scenarios, and you really don't know what's going to be landing on your network. And in these cases, you think a little bit differently. In the case of roaming, for example, you have your subscribers who need to have a similar level of experience that they have in your network using your services when they go abroad, and you need to find a way somehow to guarantee this or ensure that it's delivered, even though you no longer are the one providing the network. They're no longer using your resources, but you're still the owner of that experience. So how can I automate, for example, the analysis of what's happening just to get connected to a network? And when I get connected, the availability of the various services. How can I define what a good roaming experience looks like and automatically identify when not just a roamer is having a bad experience, but maybe a high value roamer? Start segmenting that experience as well to make sure I'm proactively engaging with my customers, even when they're not at home. So roaming experience, both the scoring and the management, is something that machine learning can help to automate in terms of identifying experience events that may be worthy of and maybe a human taking steps to resolve, but just to bring it to the attention without having to look through the millions of unique subscribers out there in the world. Another scenario, if you could just switch again for me, please, is the automated detection of anomalies. Now, anomalies is obviously very broad, and this can range from anything from identifying potential fraud in your network, identifying cybersecurity events, identifying maybe abnormal behavior in traffic or KPI performance, but just the ability to take away that dependence on someone either reporting a problem. I remember there was a report that was made by Gartner some time ago that said something like 72% of faults are learned after a customer has reported it. So it's discovered after it's already having a customer impact. And if we link it back to the previous example, the experience has already been impacted, has already been damaged before we learn about the problem. So automating the analysis of KPI trends and traffic parameters and the behavior of the network, but also the subscriber, and identifying when maybe human or automated intervention is necessary, is another key use case that I think not only is interesting, but has been neglected. It's one of the lower hanging fruits when we talk about automation and AI before we get to some of the more complicated use cases that we've been talking about so far. Again, there are a wide range of use cases, and if you go to the next one, we can also look in the domain of transparency. In the future, we expect machine type communication to be a huge contributor to not just unique connections globally, but also the revenues, the bottom line of telcos globally. Today, however, we have a big problem of understanding what is connected to my network. What devices are there? What are their needs? What are their usage patterns? What type of traffic and signaling events are they generating? Where are they coming from? Is it even okay? Is it something I want in my network? So today, we don't have that level of transparency. One of the key use cases we can do for automation is automatically detecting, for example, the presence of machines in our network. This one is particularly interesting for me because recently my team and I decided to tackle this question of transparency. How can we automatically determine whether a connected SIM card is actually machine type communication or human type communication, keeping in mind, again, the complexities of networks. You don't always see everything that SIM card does. You may not actually have full visibility on the home network it's owned by. There's a lot of complexity here, but can we use machine learning and data science to do it? And so we dug a little bit deeper and we found out there is a way. If you can define using, for example, supervised learning and machine learning, define a set of features that describe the behavior of the typical human and the typical machine using a wide enough data set so that it can generalize. You then are able to pick out the humans from the machines and you can apply this. So how, for example, if you follow up on this use case, can you apply this? The first thing you want to do is understand where are they? And what percentage of my business is attributed to these different types of roamer segments. And if you actually go to the next slide, we'll start an analysis that we did for one of our customers. Now, COVID-19 obviously has been the talk of the town for a long time. And one of the obvious impacts it's had in roaming is that people no longer travel. We're all having to stay home, unable to visit friends and go on vacation. But two things are obvious from this slide, and this is based on real data that we were able to capture, process, and analyze. And this is just the results that we're sharing with you here. There were also people who, for example, were trapped in roaming, as in people who were in destinations and were not able to fly back home, so they were there. So roaming didn't just disappear, it just slowed down for a minute and then it actually significantly reduced. But then with machine learning and this ability to automatically identify types of roamers, so humans versus machine as a fundamental classification, we were able to then decompose what's remaining and see what's there. So we saw, although a significant proportion of roamers were still human, almost half, 25 to 30% were actually machines. And if you look at the fact that they're still utilizing the network, they're still generating usage to some extent, and in a real way contributing to the bottom line, we can see how through COVID-19, it's becoming more apparent that M2M and IoT global connectivity is a real thing. It's really happening, and it's actually already significantly a part of the roamer base if you start to dig in and open that up. Now, if you went to the next slide for me, the next step is to say, okay, I can see this distinction between who are my humans and who are the machines in roaming. If I wanted, well, before I get there, we also need to think about the two sides of roaming, the home networks and the receiving networks, the visited networks. And we decided to do this analysis assuming that we were the visited network. So we needed, in this case, or this use case, to understand what are they doing on my network? How is it positively or not contributing to my bottom line? And is there anything I can do to either leverage this or ensure at least that I'm optimized to meet this challenge? So we started looking. We were able to, first of all, remove all the humans. So we take away all the data related to normal retail human roaming and just look at the devices themselves. And you see that, okay, within the M2M or machine type roaming, there definitely are different classes of use cases as well. There's some where there's almost no usage, so they're really just camping on the network and not really adding to my bottom line. There are others where they're data hungry use cases, and it begs the question, is there a business case here to maybe try and attract more of this type of device with this type of connected use case? There are some that use SMS and data, and it opens up question like, okay, why would a connected modem be needing both SMS and data? And you look at the actual device type and you see, okay, maybe it uses SMS to wake it up so that it can then use data to send an update of its status to some cloud environment. So using machine learning it starts with the data, and it's a tiered approach, and it's also very much research. It's about opening up the book and seeing the different stories that you see, and then applying that to today's problems to help solve those and actually make the most of what you can from the network and resources that you have today. Obviously, though, you still need to take a look at what's in the future. And I think that's something that you've already touched on at the start of the presentation. And if you go to my next slide, what I would emphasize is when we're looking at the automation use cases or the machine learning use cases in telecoms, looking at both what's happening now in reality today, but also what's coming down the pipeline in the future, we need to have clear targets in mind. Even in the scope of automation, not everything necessarily needs to be automated. And probably more importantly, not everything needs to be automated the way it is currently done. So reviewing processes, reviewing the way we do things to make sure that this is the right way of doing it, and then seeing how to automate that is also a step that needs to be taken. So having a clear view of what the target is extremely important. What use case am I trying to achieve, and what does that mean for my business? Two, Do I have the data to support this use case? If I wanted to automate energy savings, do I have enough historical data to understand how energy in my network works? Do I know, for example, the energy usage gradients between X region and the other? Is the data there to support whatever project I want to embark on? The next thing is, do I have the resources inside my organization? For a lot of operators, this answer is yes. They may already have invested in data engineers and data scientists, and they have the expertise necessary to start the projects, and they have the relationships with vendors to do that. In some cases, they don't. So, 5-10 years from now, when we have, fully SDN and NFV networks, and we have 5G already going strong, um, you need to start today to have the resources in-house that will actually make use of the opportunities coming down the line. So get the resources you need and the skill sets, and start building multidisciplinary teams that can do the research today for the solutions tomorrow. And then, each use case will require different approaches. Probably I won't go too much into the approaches, but just know that there's a lot of buzzwords and there's a lot of jargons. It's important to understand what it is you're trying to achieve and understand what methods are best aligned with that target. In our case, for example, for the machine identification, we used a combination of machine learning models or techniques, which incorporated both supervised and unsupervised learning. Whenever you start your project, you'll quickly start finding out what is necessary. And then finally, it's research. Okay, so don't expect quick wins. Whatever the project is, if it's to fully automate your network design, or if you zero touch network configuration, or if something as simple as being able to find anomalies in your network and automatically identify fraud and security threats, whatever the case is, research is necessary. There's a lot of industry experts doing the research for you, so leverage what's available there. But when you're applying that to your business, your needs, and your use cases, you need to also do that research internally to see if you can actually achieve it. And don't forget that failure is not forbidden. Sometimes you have to fail to learn, and that will happen in any automation, machine learning, or data science project. And that's pretty much what I wanted to share. There's a wide range, but the struggle is finding the right use cases for me as a player.
Hey, thank you very much for taking us through that presentation, Damien, and sharing your perspective. Now I'm going to turn it over to Prakash.
Thanks, Sean. Thanks everybody for joining us today. We got an interesting subject. I'll take a little bit of a different approach, a look at how AI and ML can enhance 5G network performance, efficiency, which kind of plays into the automation as well. Next slide, please, Sean. So before you go there, as Sean mentioned, I'm a founder and principal of Tantra Analysts. We are a boutique industry analyst firm covering 5G, AI, IoT, IPR, and many tech areas. Okay, so there has been a clear trend in terms of distributed AI. I know we started with the cloud-centric AI, wherein you would haul all the data to a centralized cloud, all the data crunching and AI would happen there, and only execution happening at the edge. But in recent last couple of years, there's a lot of on-device AI. So it's now cloud as well as on-device AI for very good reasons. A lot of use cases are there where you need immediacy, very low latency support. So you can't expect sending the data to cloud and the distance to come from the cloud for you to execute. So for a lot of those cases, the AI is happening on the device, and there's a lot of personalization as well that clearly has to happen because of privacy reasons on the device. But also there is move towards edge cloud, the cloud in between. Edge cloud is cloud infrastructure that is close to the edge, close to the user or close to the device, but more capabilities in terms of processing and such. So my view is the AI will be distributed, between cloud, edge, as well as edge cloud. Why? As I said, starting from device, there's a lot of use cases where you need immediacy and on-device AI. but there are many others where you can get there is opportunity to get even better perspective from cloud, AI, and such. And of course, as we know, the processing capability, even with the modern devices with good processors and such, the processing capability is still limited compared to what can be done in cloud, for example. And we have the biggest challenge of having battery life, because we would want full day or more of battery life on our devices and such. So there is need for on edge on device AI, but there are limitations on how much we could do, right? And then we look at the other extreme, cloud. Cloud has, you can have unlimited amount of processing power, so you can crunch huge amounts of data sets and come with what I call meta learnings for the cloud and the edge cloud and the devices to do. So that's on the other side. And the edge cloud is basically has more processing power and and capabilities than a device for sure, and it is close enough that it can support many of the latency sensitive use cases that definitely doesn't need extreme latency sensitivity as some of the use cases might. So there is a clear need for there as well. So all in all, you'll have AI distributed across the network and used as needed basis. Next slide, please. And why most of the data that AI needs to work on data sets is generated on the devices. So because of the sensors, because of the personal data, because the all the things devices do, all of data is collected. It's huge amount of data. It would be not feasible and not smart enough to send all of that raw data to the cloud for processing. So that's the reason why you need distributed AI crunching that data sets at different levels based on the need of the use case of the application and kind of data and the learning that you have to do. Next slide, please. And overall, if you look at AI, it is very well suited for the challenges that wireless link provides. Wireless is a very complex challenge. Wireless link analysis and adaptation. In my previous life as RF engineer, people used to call RF wireless and RF as a black art because there's so many dimensions, so many different variables where it changes. So AI is very well suited for such analysis and addressing challenges. Why? A lot of times it's very hard to model wireless challenge. For example, as RF planners and network planners, you do simulations and the predictions of the network behavior and such. Even with the computing power that you have, what you can only do is different snapshot of the network. You cannot just create a totally dynamic network as the actual networks are to do the predictions and behavioral analysis. And it is almost impossible to do with the traditional compute. So that's you need where AI can come in and make these models possible for predictions and simulations and such for studying wireless links. And again, second is computational infeasibility of doing these things in a large scale. With the traditional approach, you just can't do. And there are so many variables in wireless link and networks, and with 5G it's increasing manifold. So looking at and considering all those variables and still analyzing what is the best setting to do. For example, the networks has tons of knobs. It is almost impossible for a traditional approach to look at what is the most feasible and most optimal settings for all those parameters for perfect network operation. And a lot of times and often the situation and the behavior keeps changing, so you have to quickly adapt to those changing network scenarios. So that is impossible to do for a static kind of approach and with traditional approach, and that's where AI shines. And as evident, most of these challenges are non-linear, and again AI is best suited for that with the with the abilities to look at these complex challenges that are non-linear and looking at complex dynamics of the network and addressing and coming up with best suitable and optimal solutions. Next slide, please. And there are, AI can be, as I said, since it's distributed, there are advantages and why AI can do at the network side, on the edge side, and in between on the edge clouds as well. Looking at from a network point of view, first one is the biggest and the lowest hanging fruit, I would say, is improving network efficiency. Let me give you a quick example. All the networks in the world, wireless networks, are designed and provisioned for peak hour traffic. And guess what? That peak hour traffic happens in only one of the 24 hours, which means the remaining 23 hours of the day, the equipment that you have installed and operating and running is sitting idle, right? And the network peak is different in different places of the network, which means you are over provision the whole network, for this one peak hour of the day, which might be different in different parts of the network, as I said. And that is not the best way to run a network and deploy a network. And obviously, the return on investment is very low. But that's exactly what we are doing today, in absence of many other dynamic ways of managing the network. With AI, especially when the network is cloud native, as we were talking about in the earlier slides, as Sean and Tariq mentioned, you have opportunity wherein instead of this having individual sites with their own resources, we have pooled resources which are addressing multiple sites, multiple locations and such. In such case, you can use AI to use the resource and the resource utilization and scheduling and such much more efficiently based on what is needed rather than, and when it is needed, rather than just some static allocation, which is not really efficient. So, extremely important point is you can increase the network efficiency by leaps and bounds by using AI in the network. Service quality. Sean and Damien mentioned about this network slicing, where you have to provide the specific SLA signed characteristics and performance to specific use cases and the users. And that can be better managed efficiently with AI rather than a static allocation, which may not be very efficient. And you can basically keep changing based on the user behavior and the network behavior as well with AI. SON, we have heard of SON for a very long time, but SON can be extremely efficient and very well managed with AI, as you would agree. Self-organizing network by definition needs a lot of intelligence and smarts in it, and AI can do that very well. A good example is with millimeter wave. We'll have dense deployment of networks, and typically networks are designed with a set of inputs and assumptions when you design the network. Once you deploy it, those assumptions may or may not be valid. So in that case, you basically network has to adapt to the existing scenario, and in SON can be extremely useful there, and AI can do it much better than anybody else. Network security, Damien mentioned about this too. With AI, you can quickly modify the anomalies in the network and the user behavior and address the challenges, security challenges like hacking and such on the tracks, and stop them on the tracks. Identify much before the damage is done. Be proactive and stop those hacks and attacks in the tracks rather than after the fact, when where you can't do much about it. Next slide, please. Now that was the network side. Now looking on the device side, with 5G, we have tons of different spectrum bands, types and types of connections, and with different characters with network slicing and such. With the AI on device, you can select best band and the channel that you want to on right away. The traditional approach is you go sequentially, you go through, try to look at all the channels and then select the best one. But if with the on-device AI, based on your context and location and everything, what could be a best channel for you and best access for you, and go there right away. So that improves efficiency as well as the user experience for sure. And with different kinds of accesses, you can select the right one right away rather than just going through a list of things and selecting what is best for you. Contextual awareness, again, with so much of different parameters and so much of different complications in 5G connectivity and types of characteristics of the connections, device based on its location, based on its position, based on velocity, RF scenario, and types of use cases you're doing, what is the battery life left on the device, for example, and such. With full range of variables in the device can select the best access and best way to interact with the network with AI in a much better way that was not possible before. And same with RF sensing. Depending on the context and the RF characteristics of the device, you can make much better choice and and also enable very new use cases. I have a couple of examples on the next slide. Next slide, please. So, going back to again this complex link that we have, which is wireless link, the way it is done right now, because the RF characteristics of every user and every scenario is different, we have mechanisms like different codes that you use based on the signal strength and interference scenario. You have different, you adopt the network link for different data rates and different coding and so on. Right now, it is based on trial and error. You try to match and adapt the networks to what is possible. But with AI, based on context, you can use the most optimal setup and the configuration right away, rather than doing mixing and matching and trial and error. So that improves efficiency by a large amount. And with the millimeter wave and even with a regular mid-band and low-band spectrum, you have MIMO and beam forming and beam steering. Lot of cases, beam steering is a complex challenge, and it is very compute intensive, and it's very hard to find best beam steering. If you're doing purely trial and error basis, which is right now, you have a pilot which is tracking the user and trying to steer the beam. But with AI, again, with the user behavior and location and other contextual awareness things, you can do much better beam steering than otherwise with AI. Another important aspect is seamless mobility. With 5G, we'll have different kinds of networks. There'll be indoor networks, there'll be, millimeter wave on multiple bands, there'll be private networks, and so on. When you're moving between these two, if you're taking a traditional approach for handoff, there could be a lot of call drops, interruption in service, lots of user interruptions and such. But with AI, you can do predictive handoffs when you're moving between the networks and have a very seamless user experience. And it is even more crucial for mission critical services where you cannot, where you need huge reliability and cannot expect a call drop to happen, right? So those kinds of things, I think AI will be, it's not a good to have, but a must to make those use cases reality. Next slide, please. A quick on user. I mean, there are tons of use cases. It's a couple of webinars on its own, the subject itself. I'm giving two simple examples here. The first one, and how you on-device AI or the distributed AI can improve the use cases and experience. If you take modern factories where you have robots with wireless links and untethered robots moving around, a lot of times they may not have line of sight if it is a millimeter wave network, for example. And then with beam steering and others with multipaths coming in, it is a trial and error process to get to the best signal. But with AI, knowing that a robot in a given factory can only move around certain spaces and can be there at specific times and during specific tasks, you can basically do that positioning and multipath detection and coordination with AI much better, and improve the efficiency that way rather than the traditional approach. And the second one is detecting the motion detection and gestures. Consider a wearable 5G device on an elder, and with the with the movement and with the gestures, it can detect a fall, for example. And as many of us would know, seniors living on their own, falling and fracturing themselves is a major issue. A lot of times it is very hard for the healthcare workers to even know that their fall has happened and get to them very quickly. With a 5G wearable which can detect a fall, for example, and immediately report to healthcare system or call a 911, you can alleviate that situation. I mean, these are simple small examples, but kind of highlight the use cases that are enabled by AI on device as well as through distributed AI. Next slide, please. So to summarize, I mean, AI, distributed AI, and the end-to-end benefit end-to-end 5G system. It can improve the network performance and efficiency. It can improve device performance and efficiency, and of course, it can significantly enhance user experience. With that, take it away, Sean.
Yeah, thank you very much, Prakash. Gentlemen, let's turn the cameras on and answer a few questions here. And we might run a few minutes past the hour, but I'd encourage people to stick around. We'll take a few of these. This is a good one, Damien. Maybe you can address this. You mentioned the buzzwords that are going through the industry as it's related to AI, ML, and zero touch is certainly one of those. So the question is, are there any functional areas like RF, quality of service, or security that are at or close to that objective of zero touch?
So in a lot of ways, yes. I think the first thing to say quickly is uh, we've always, I think, there's always been the possibility to just truly automate networks. But I think, especially with the promise of 5G, we see a much faster uptake of the concept and also the products around SDN and NFV networks. And automation needs this software and virtualized network, software-defined and virtualized network concept to be in full swing. That said, if we take RF, for example, the fact we have no Open RAN, so the ability to actually decouple parts of the radio access network from vendor-specific hardware and actually replicate that in software allows us to almost at this point look at the possibility of dynamically allocating radio resources, retuning the network based on what's happening in real time. The same thing as well in a lot of customer interactions or actually customer facing platforms. I mentioned before CRM. There are deployments of customer relations management, which is almost zero touch. I mean, again, once the data is solid and it is reliable and you have enough of it to make autonomous or semi-autonomous decisions, this is feasible. So today, I'd say in terms of almost zero touch, we're looking a lot on the customer relationship and marketing, but also in the network itself, routing decisions, capacity allocations, in some cases, energy planning. But for sure, I think Open RAN is probably the best example of being able to almost automate radio resources allocation.
Yeah, that's a really good point. And Prakash, maybe I'd get you to weigh in here. You talked about SON as it relates to millimeter wave, very dense networks where we might see baseband centralized and then connected out to radio heads, but you're doing that management and optimization in a central manner. When we talk about Open RAN, you'll talk a lot about real-time and near real-time intelligent controller, RIC, that's deployed there with the Open RAN server. So do you feel like with the advent of the RIC out there in the network that we're getting closer to an actual AI or intelligent process that's optimizing and allocating radio resources?
Absolutely. So RIC is basically edge node, right? Edge cloud, if you will. So, I mean, currently, if you look at, we're still virtualization and Open RAN is starting to happen. The current models will still look at real-time data and make real-time decisions. Not so much using AI right now, but going forward, when you have huge amounts of data sets, you can not only make real-time decisions on real-time data, but look at more predictive decisions as well. For example, which sites we are going to have traffic congestion at what times of the day, for example, or certain things are happening in the network. For example, a big rally is happening somewhere, so that, and people are moving. There is traffic moving to a specific area and such. So you can be much more predictive in terms of addressing the needs of the network rather than just only real time. Right? Real time is perfect. But again, if it can be predictive, it will be even better than real time, in my view. And that's where I think the system is headed. And the virtualized network and cloud native networks with open and virtualized RAN, it is perfect set for it. Earlier case, even if you had the intelligence, there were no ways to implement this better resource allocation and such. Yeah.
All right, here's another interesting question, and I'll refer back to the examples that I gave. And to be perfectly clear, those are examples of autonomous network processes, but they're trials. They're not at scale. They're not really commercial today. So this is something that's in the future. But Damien, maybe you can look ahead for us. And the question here is, the concepts we discussed today, like network slicing, when do you think we will actually see this made available on public-private networks? And any thoughts on what types of use cases or vertical industries might be at the leading edge of adoption there?
So network slicing obviously is linked closer to the evolution of 5G adoption. Today it's promising, depending on which market you look at, the US, parts of Asia, parts of Europe. It seems like the adoption may be going at a better pace than 4G or LTE was, but keep in mind that there's still networks in the world that don't have an LTE network. So there's a question mark there. That said, I'm excited about the next 5 to 10 years to see where we are. For sure, the capabilities of network slicing and also the latency and high capacity and also massive connectivity promise of 5G is almost purely linked to IoT. So the verticals there are going to be, for example, Industry 4.0 use cases. And it's interesting to look maybe the next 2 years in countries where 5G is rolled out, what the COVID-19 vaccine distribution strategy is going to look like. If you think about it, being able to track in real time where these millions of vials are, how they're being transported, making sure the cold chain isn't broken. So the healthcare vertical is also there. There's a lot of promising use cases. As to the timeline, to be honest with you, it depends on which industry report you read. It has to be taken into a region by region case.
Let me add a quick thing. So, I know, especially when it comes to industry, there are, I think, two ways of addressing. One, you're seeing a lot of private networks happening as well, a lot of traction there. So, if you have a fixed in industry or industrial complex or a campus and such where you need these kinds of dedicated specific configurations that network slicing allows, then you would go towards private network. But any use cases like the great example that Damien gave for tracking on real time the COVID vials, where there are mobile, they're going all across the network. There, I think you'll see a lot of traction on network slicing. So it depends which use cases develop how soon. I think COVID is a great use case that Damien mentioned.
Well, gentlemen, we've run a little long here. We've got a few more questions to our audience. We're going to log these and we can follow up with you on a case-by-case basis to get these answered. But Damien, Prakash, I really appreciate you taking the time to have this discussion with me about where we are today with AI and ML in the network and really where we're going in the future. So I appreciate your time, and for everybody that stayed along with us, thank you so much for joining our discussion today.
Thank you.
Thanks a lot, Sean. That was great.
It was really nice.